Hey, hi. Today I will teach you what is arithmetic progression, its introduction, common difference, finite and infinite arithmetic progressions, etc. etc. First, I will write a list of numbers 2, 4, 6, comma 8, comma etc. 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 I mean, numbers will continue till infinity. This dot represents numbers will continue till infinity. Now this is called this list of numbers. Numbers are 2, 4, 6, 8, etc. etc. This is list of numbers. Now the point is when this list of numbers will become AP means arithmetic progression. This A, this P is here. Okay. AP is the short form of this arithmetic progression. Now, when this list will become arithmetic progression. Now, to understand the definition of this arithmetic progression, don't consider this first term. This 2 is the first term. Okay. Now, the definition for arithmetic progression. You take this term or this term or this term. Don't consider this term, first term, because there is no previous term to this term. Here there is no term, right? Nothing is there. Nothing is there. There is no term. That means there is no previous term for this 2. So consider other terms except this first term. This is first term. Now see, we get 4 when we add a 2 for this previous term 2. See, plus 2. If you add plus 2 for the previous term, you are considering this term 4. 2 is the previous term for this 4 term. When you add plus 2, when you add 2 for this previous term, you will get 4, because 2 plus 2 is equal to 4. Similarly, consider the 6. 4 is the previous term for this 6. When you add 2, I mean plus 2 for this previous term 4, we get 6, because 4 plus 2, 6. Similarly for 8, 6 is the previous term. If you add plus 2 for the 6, 6 plus 2 is equal to 8. We get 8. Now the definition for AP. Each term, I mean this 4 or 6 or 8 or etc. etc. Each term except this first term. Okay. Each term except this first term in a list of these numbers is obtained by adding a fixed number to the previous term. For 4 this is previous term, for 6 this is 4 term. For previous terms we added fixed number, here also plus 2, here also plus 2, here also plus 2. Okay, then we got this. So now this is called AP. This list of numbers is AP, arithmetic progression. Okay, once again I will repeat. Each term of a list of numbers except this first term is obtained by adding fixed number to the previous terms. Okay, for 4 this is 2, for 6 this is 4. For 6, 4 is the previous term. So this is the definition of AP. Each term of a list of number except the first term is obtained by adding a fixed number, I mean 2, same number. We have to add same number to the previous terms. So this is called AP. Now this fixed number is there, no, 2. This is called common difference of this AP. So common difference is represented by D. this 2 is the common difference of AP. So in this case, D is equal to 2. This 2. Okay. Here we have plus 2, right? Just 2 means that is plus 2 only. This common difference can be positive or negative or 0 also. Okay. Examples for negative common difference. This one. 100, 70, 40, 10, etc., etc., etc. So this is the AP with common difference is negative. For example, before that, I have to show negative common difference, right? Before that, see, if you take this first term as A1, this is a second term as A2, and this third term as A3, A4, etc., etc., etc. Common difference will be, don't subtract next number from the first number or previous number. See, to get the common difference, you have to subtract 100 from this 70. 70 minus 100. Don't do 100 minus 70 or 70 minus 40 or 40 minus 10. That is wrong. To get the common difference, 70 minus 100 you have to do. Here 40 minus 70, 10 minus 40. I mean, in general, see, I have taken A1, A2, A3, right? Common difference D will be this A2 minus A1. A2 minus of A1, or you can write A3 minus A2. A3 minus A2. Another A4 minus A3. Okay. A2 minus A1, A3 minus A2, A4 minus A3 all give the same common difference D only. This, see, A2 minus A1, not A1 minus A2. Very important. Here also A3 minus A2. Okay. Very careful. I said negative common. This is example for negative common difference. So you will get it. A2 is what? 70 minus A1 is what? This 100. 70 minus 100 is minus 30. Correct? 100 minus 70, 30. So in front of this bigger number, negative minus is there. Minus we will put minus 30. So minus 30 is the common difference. Here also we will get same. See, A3 minus A2, 40 minus 70, that is equal to minus 30. Here A4 minus A3, I mean 10 minus 40 is equal to minus 30. Common difference will be same whether you use this or what. See, you got negative common difference. So common difference can be positive, negative, and I said common difference can be 0 also. I will give example for 0. Okay. Example for negative common difference. 4, 4, 4, 4, etc., etc., etc. See, if you take this is E1, A1, A2, A3, A4, etc., etc. So as you have seen, the common difference D is equal to A2 minus A1. A2 minus A1. A2 is 4. A1 is also 4. 4 minus 4 is equal to 0. This is the common difference. Okay. So common difference can be positive, it can be negative, it can be 0 also. I use the term previous term, right? Like for 4, 2 is the previous term. Previous term we also call it as preceding term. Preceding term, both are same. Now we will see the general form of AP. In general, for example, we know first term A. A means first term, we know first term, we know common difference D. When we know this A and D, what is the general form of AP? So general form of AP is A comma A plus D comma A plus 2D comma A plus 3D, etc., etc., etc. This is the general form. This is the general form of AP. Okay, remember this. Next, there are two APs. One is finite AP, another one is infinite AP. Finite AP, infinite AP. See, finite AP is the AP that has last term. For example, I will take this first four things 2, 4, 6, 8. I will put away. See here I mentioned dot, right? This numbers will continue till infinity. So that time this will become infinite AP. So this is infinite AP. 2, 4, 6, 8, etc., etc., etc. Okay, numbers will continue till infinity in this AP. So this is infinite AP. Here numbers will stop here only. Numbers will not continue. This is finite AP. Okay. The finite AP is the AP that has last term. So 8 is the last term. It has last term. But in this case, see, numbers will continue indefinitely till infinity. We cannot identify which is the last term. So infinite AP is the AP that does not have last term. Okay, it does not have last term. So this is infinite AP. So examples are this. I hope you understand. Next, I will just give real life examples. Real life examples for AP. For example, in a class, some students are standing in a queue. If their heights are measured in centimeters, for example, say, then we get the measurements heights like this, like 145, 146, 147, 148, like this. Okay, so this is real life example for AP. Heights of students measured in centimeters. Okay, see, if you add 1 for this 145, we get this. Again, if you add 146 plus 1, 147. Plus 1, if we add 147 plus 1 is 148. Okay, so this is an AP. As we have seen the definition of AP. So heights of students. Okay, this is an AP example for real life example. Heights of students is real life examples. This is first example. Second example, for example, movie theater tickets rate are increasing every year. Okay, ticket rate in first year 100 rupees. Movie theater ticket rate is 100 rupees in the first year. Second year they increase to 120. Third year they increase to 140. Fourth year they increase to 160. Right? So now this ticket rates hike or increase in subsequent years. This will become the AP, because see, if you take 100, if you add 20 plus 20, 100 plus 20 is 120. Again, if you add plus 20 here, 120 plus 20 is we get 140. Okay, next year if you add plus 20, 140, this plus 20 is equal to 160. So this is an AP. Okay, That's all about this arithmetic progression today. Hey, if you like this, please click on like and subscribe. Thank you.